All right, thank you so much for joining us today. In this video, we are going to talk about definite integrals, fundamental theorem of calculus, and we take example, then I'll give you a trial question to try, right? So what is definite integrals? In the previous video, we talked about indefinite integrals, right? And then we saw that indefinite integrals are of the form, let's something like this, without anything here. So it means that automatically definite integrals are of the form this, f of x dx. So these are definite what? Integrals. These are definite integrals. So it means that when I integrate this, I'm not going to get, a function that I differentiated, because of the limit here. When I differentiate the function, I'm going to get a specific value for the definite aspect, right? Now let's talk about fundamental theorem of calculus, right? So we are saying that if f is continuous at any point in this, and f is the antiderivative of this on this, then this, which is the definite integrals here, using the fundamental theorem, we are going to say that this is the same as big F of x, right? Because this big F of s is the integration of this. And then we are going to put the limit on it, and we are going to have big F of b minus big F of a. So plug in the upper limit inside the function minus the lower limit inside the function. And this is the famous fundamental theorem of calculus. Like anytime you have function which has a limit here and limit here. So a is the lower limit and b is the upper limit of the integration. Now we can also use the definite integrals or the fundamental theorem to find area under the curve, right? So the area function is basically this. So when I have function like this and x is in between, let me say a and b, then I can find the area of that particular function. So that is the fundamental theorem. Now let's look at some properties of definite integrals, right? And then we just look at what we are going to do. Now, anytime I'm integrating, remember what we just did here, fundamental theorem. I need to have b, f of b minus f of a. So when anytime I have this one, this is going to give us something like this, f of a to a, and this is going to give us big A minus big F of a, and this one is going to give us 0. So what you need to know is anytime you have the same limit, the integration goes to 0. So that's one thing that you need to also know from here. Now another thing that we need to learn from here is this, as we've learned, this we can write this one as minus a to b f of x dx. So why am I writing the minus? I can write this one minus and switch the order, right? Because we know that we subtract, right? So if I'm doing this, I'm going to have big F of a minus big F of b. So when I subtract it and swap the order, this is going to be minus, and I'm going to have this one to be b and this one to be a. And when I multiply the minus 2, I get the same thing here. So anytime I have a function like this, I can swap the order, right? So I can swap the order. When you want to swap the order of the integration, you need to bring negative here. So that's another property. Now this one too can be written as this. We can combine this one and write it as integration from a to b f of x dx. So what do? We brought in this one is supposed to be c. So we can combine integration from a to b, and you can see that the same b is here. So the b here is here. So it means that we can combine this integration by starting from a to c. This is inside this. So it means that if I have integration from a to c, then I can split it into this. For example, if I have integration from minus 1 to this of f of x dx, then I can write this one as integration from minus 1 to 0 of f of x dx plus from 0 to 1 of f of x dx. So that's basically what we are talking about here. So we can pick a number which is between minus 1 and 1 and then use it to do the integrals. Now this one too can be written as, this one I can just factor c out, or let me just say that when I'm integrating a constant using this one, I'm going to have, we know that when you integrate a constant, you need to multiply it by this. But this one, you are not going to add a constant because we have the limit. So I can put a here and b here, something like this. So this is what I'm going to have when I want to integrate this function there. And same thing for this one too. I can write this one as ab f of x dx plus or minus ab gen of x dx. And then the same thing for this one too. I can factor c out and write this one as this dx ab. Good. So these are some of the properties that we need to learn so far as definite integrals is concerned. Let's take some example. Oh, okay. Okay, so I wanted to show you what we learned from the previous video. So the basic integral functions, we said this is equal to this. So when I'm integrating this, I have this one here. We saw for the exponential function, we saw for the length function, we saw for exponential function here, and then this is the power function, this is the exponential function, and then constant base function, and then we saw the trig functions. When we differentiate the trig functions, what we are going to get, I think they are all here. So I just wanted to show you. Okay, let's take some example. Now let's use the idea of the fundamental theorem that we just learned. So I want to integrate this function from 0 to 2. Now what you just need to pay attention here is anytime you have been given some question like this, look for the function which has the highest interval. So look at the intervals. So the interval given to us is 2 to 3, which is from here. Then we have 0 to 3, which is from here, and then we have from here to we have from 0 to 2. So which interval is going to include the other intervals? That's what you need to look for. So you see that from 0 to 3, we can find from 0 to 2, and we can also find from 2 to 3. They are all inside this. So that is what you need to know. Anytime you want to solve question like this, look for the interval that is included everything. So you see that this is inside this is also inside this. So it means that I will start by writing this one as integration from 0 to 3 f of x dx. And this one will help me to write this two integration by combining this and that. So I can write this one as from 0 to 2 of f of x, because it's left with this, and this is from 0 to 2 and from 2 to 3. So I'm going to have this and then plus from 2 to what? 3 f of x dx. But the question is asking us to find this. But the question is, do you know this and do you know this? Let's go and find out. So I think we have this here, which is right here, right? So we know that this is 3, which is equal to this one we don't know. But we have the one which has interval from 0 to 3 and 0 to 3. But this one is multiplied by 2. So what I'm going to do is I'm going to pick this one and make sure that I don't have the 2 there. So I'm going to write this one as f of this is equal to 4, which is from 2 to 3. Now from the properties, we can factor 2 out. So factor 2 out and get something like this. Divide through by 2 and we are going to have something like this. Is equal to 2. So it means that this right here is equal to 2. So I can write this one to plus 2. Good. So now that I have this one, then I can find for this one by moving this one to the left. So I'm going to have this to 2 f of x dx is equal to 3 minus 2 and is equal to 1. So anytime you have a question of this form, remember to play it very well. For example, you saw that this is the property that we're just using. You can, some of them, you need to swap the interval by putting the minus there and stuff. All right. So that's the first example that I wanted us to go through. Let's look at example 2. So we are just come to do some integration here. So this is equal to, when I integrate sine, I get cos. So this is going to be cos t, then from 0 to 2 pi. and then I plug in 2 pi, so cos 2 pi minus cos 0. What is cos 2 pi? Cos 2 pi is going to give us 1, right? Minus 1, and this is going to give us 0. So cos 2 pi is 1, and then cos 0 is also 1. So we are going to get 0 from there. Now let's integrate this one. So we can see that we have a constant here, so we can factor the constant out and have 1 to 2, 1 divided by x dx. And since the degree is 1, we need to think about the ln function. So this is going to give us ln of x from, we need to bring the 3, from 1 to 2, and this is going to give us plug in 2 minus plug in 1, and we are going to have 3 out, ln of 2 minus ln of 1. What is ln 1? Ln 1 is 0, so I'm going to have ln 2 minus 0, and this is going to give us 3 ln 2. So they are pretty straightforward. Now let's look at this one too. I want to integrate e to the power x. So I integrate e to the power x, I maintain the function, I divide it by the derivative of what is on the top. But when I differentiate x, I get 1. So this is just divided by 1, and it's going to be the same thing. And then I'll put from 0 to ln of 8 here, and this will be e to the power ln 8 minus e to the power 0. Now this is equal to, this is going to give us 1, so this is going to give us 8 minus e to the power 0 is 1, and this is going to give us a big 7. Good. Let's look at this one too. This one we need to simplify before we integrate. So x plus x to the power 1 over 2 or dx, right? And this is going to give us, this is to the power 1, so we add plus 1, so this is going to give us x squared divided by 2 plus add plus 1 to the half. So you are going to have 2, you are going to have 3 over 2 divided by 3 over 2. Then we integrate from 0 to 1. So this is going to give us x squared divided by 2 plus 2 on 3 x 3 on 2 from 0 to 1. So plug in 1, plug in 0. So when I plug in 1, I get 1 squared divided by 2 plus 2 over 3, 1, 2 over 3 over 2, minus, when I plug in 0, I'm going to have 0. So I'm going to have 1 over 2 plus 2 over 3. And using my magic, this multiplies this, get 3. This multiply this, plus 4 divided by this multiply this, gets 6. So this should be 7 over 6. So we are going to have 7 over 6 for this one. Good. We are going to have 7 over 6 for this one. Good. So now let's look at this question also here. This, we don't need to simplify. You can do the integration straight, right? So integrate x squared and add plus 1 divided by that, plus this is to the power 1. So I'm going to have x2 divided by 2 from minus 1 to 1, right? Plug in 1, plug in minus 1. So when I plug in 1, I have 1 to the power 3 divided by 3 plus 3 on 2, 1 squared, minus, plug in minus 1, minus 1 to the power 3 divided by 3 plus 3 on 2 minus 1 squared. So this is 1 over 3 plus 3 on 2 minus, this is minus 1 over 3 plus 3 on 2. So we just did something like, okay, it's not the same thing. So this one is going to give us 2 plus 9 divided by 6. So this times this, and this times that, and divided by this times that. You can use calculator to verify from there. Then this is going to give us minus 2 plus 9 divided by 6. So this is going to give us 11 divided by 6 minus 7 divided by 6. And this is going to give us, I think, 4 divided by 6, which is 2 divided by 3. So this is what you are going to get for this one too. Now let's look at this one. Integrate this. Remember, this is the constant base function. So I will maintain the function and divide it by the derivative of the top, which is going to be 1, times ln of the base, which is 2. And I evaluate it from 0 to 2. This is the same as 2 to the power x divided by ln 2 from 0 to 2. And this is going to give us plug in 2. So 2 to the power 2 divided by ln 2 minus plug in 0 ln 2. So this is going to give us 4 divided by ln 2 minus 1 divided by ln 2. So that's what you're going to get. You can just, I think you can factor ln 2 out and get something like 4 minus 1. And this is going to give us 3 divided by ln 2. Good. So this will be the final answer for this one. Good. So this is basically definite integrals, right? Here we get a specific answer. We don't get the function what we differentiated, right? Because we have the limit there. So try this and leave your final results in the comment section. So try this one here, this one here, and this one also here. Good. So I think we have 2 questions. So in the next video, we are going to talk about one technique that we can also use to do integration. We are going to talk about integration by substitution, which I call it U substitution, because most of the time we said let U. So we are going to talk about change of variables. You see, every integration that we've done in the previous video and this one is just kind of straightforward. We don't need to do any manipulations. So in the next video, we are going to talk about U substitution. See you in the next video.